Welcome to our convenience store. If you need any help finding something, feel free to ask.
And can you tell me more about this one?
Oh, that poster is promoting our fresh orange juice sale. It's going for $2 each. A nice drop from the original price of $3.50. A pretty sweet deal if you ask me.
Hey there, how are you doing?
Recent studies are using large language models to improve virtual reality chatbot interactions, focusing on dialogue from user speech. However, the potential for richer experiences through these models' perception of virtual environments and interaction cues is still unexplored. In this work, we define a schema for describing VR environments and their interactions via text prompts. System context defines the system, scenarios, and function for the avatar's actions. The characters component describes the characters, including the agent and player, and their states. The objects component details the objects within the scenario, including both fixed and movable types. Additionally, we introduce container objects as a subclass that can hold other items, which themselves also can be classified as either fixed or movable. Through the 4 object combinations, the object system identifies relationships between objects and agents. This enables designers to craft interactions of a scenario and supports agents in spatial localization and reasoning. The spot component provides information about specific locations within the scene that offer particular affordances and assists agents in navigating within the scene. The communication component manages action cues and dialogues among characters. It provides context so that agents can be aware of previous actions and conversations initiated by characters, which can assist them in generating the next interaction and communication cues. Using this schema to compile information into a text prompt provides agents with context for interactions and the latest VR environment, initiating their reactions and replies. Based on our schema, we created 5 VR roleplay scenarios in Unity, focusing on exploring various components and their combinations in scenario design. In the fruit and vegetable store scenario, an agent plays a customer wanting to buy items, and the user is the counter staff, helping the customer find all their desired items. In this scenario, the user can only provide verbal instructions or point in the direction of the item when asked by the agent and cannot physically help in retrieving any item from the scene. In the convenience store scenario, the agent acts as a counter staff member, helping users, in the role of customers, find and collect items from the shelves before they head to checkout. In this scenario, the agent, whom referred to as a lazy counter staff member, stays in one place and guides users to their desired items using only verbal instructions. In the art gallery scenario, the agent serves as a tour guide and the user assumes the role of a first-time visitor to the gallery. Users can request that the tour guide lead them on a tour during which the path through the gallery is dynamically generated by the agent. Additionally, users can ask the tour guide to introduce them to an exhibit and pose questions about it. In the game room scenario, the agent and the user engage in a move and guess game, with the agent assuming the role of the user's playmate. The user is referred to as a player. Both the agent and the user alternate moving toys from one basket to another. After each move, the task of the other player is to announce which toy was moved. In the fast food store scenario, the agent takes on the role of counterstaff, handling order requests and delivering items to the customer, portrayed by the user. The user is depicted as a first-time customer, unfamiliar with the store's menu, preferring to order primarily through implicit cues, such as pointing at items on the overhead menu board. Using these scenarios, we evaluated agents' behaviors and their impact on user experience in spatial interactions and conversations within VR through studies with 14 participants. Our findings highlight the opportunities and challenges of developing environment-aware agents within VR roleplay scenarios. For more details, please refer to our paper.